Hey guys, it's Thalia. Ew, I said that weird. But I just want y'all to know that anything's possible. And if I can get into Stanford with a full ride, then you can get 100 on the CH quiz. Bye.
Oh, some encouraging words from the great Talia Revilla, our fearless leader, our president of Cardinal. Oh wait, not Cardinal Senate. The president of Student Council. All right, here we go. So thank you, class of 2020, giving the class of 2021 some inspiring words. So let's do this, guys, and let's get right into it. A string running from the ground to the top of a fence has an angle of elevation of 45 degrees. All right, so here's the ground, wiggly lines there. Here's my fence, and here's my string. Let me make this in tablet mode. So there's my string, and the angle of elevation is 45 degrees. So the angle of elevation is always with respect to your horizon, guys. So here's my horizontal, my horizon, and there it is. So the string is 6 feet long, so I put a 6 here. What is the distance between the fence and where the string is pegged to the ground? So they want this distance here. So there's two ways to do this. You can either recognize that it's a 45, 45, 90 triangle and square root of 2. So if my hypotenuse is 6, then to get the short leg, that has to be 3 square root of 2. And in case you're wondering, like, Chavez, how did you do that so quick? Relax. N square root of 2 equals 6 divided by square root of 2 divided by square root of 2. And then you get n equals 6 divided by square root of 2. But you already know they're not going to have it like that. They're going to rationalize it. So 6 square root of 2 over 2. 2 goes into 6 3 times. So 3 square root of 2. There is another way to do it, guys. If you don't necessarily want to do it that way, you could always do adjacent over hypotenuse. So you could always say cosine of 45 degrees equals x over 6. And then you can just go 6 cosine of 45 degrees. And 45 degrees is one of the perfect angles in our unit circle. So you can say 6 times square root of 2 over 2 equals x. And you can say 2 goes into 6 3 times. Then you get 3 square root of 2 equals x. See? So there's more than one way to do this. Hold on, guys. All right. Here we go. Question 2. We're recording, right? Yeah. Question 2. Sorry, guys. Suppose that you're headed towards a plateau, 45 meters high. So here's my plateau. It's like a kind of like a cliff. And if the angle of elevation to the top of the plateau is 21 degrees, so you're right here somewhere. And angle of elevation, so if you're there, angle of elevation is 21 degrees. Here's my right angle. Here's the 21 degrees, not to scale. How far are you from the base of the plateau? So this is 45 right here. And they want this distance. So since you want that distance with respect to the 21 degrees, the 45 is opposite. The x is adjacent, so you're going to use tan. So I'm going to write tan 21 degrees equals 45 over x. And then I'm going to solve for x. So times, divide. So you're going to have x equals 45 divided by tan 21 degrees. And then I'll look for that answer. And there it is. All right. Pause it if I'm going too fast, guys, or, so you're going to need your calculator here. So this one, you're going to need your calculator. So a wire 120 feet long is attached to the top of a radio transmission tower. So these radio transmission towers are super tall. And it's 120 feet long. So here's the ground. So 120. That's going to have to be a right angle there. Making an angle of 47 degrees. With the ground. How high is the tower? Round your answer to the nearest 10 thousandths. Okay, so I want this distance. How tall is this tower here? So with respect to 47, the x is opposite. The 120 is hypotenuse. So I'm going to write sine. So sine of 47 degrees equals opposite x over 120. So 120 sine 47 degrees equals x, and I'm just going to type it in like that, guys. So I'm going to write 120, and I'm going to go sine, and I'm going to go 47 Let's see what we get. 87.7624. And there it is. Let's keep going. A ramp for wheelchair accessibility is to be constructed with an angle of elevation of 14 degrees and a final height of 4 feet. How long is the ramp? All right, so when you make a ramp, so here's the horizon or the horizontal. When you make a ramp, this is the distance of the ramp. And then this ramp went up, let's see, it said 4 feet there. So I'm going to put 4 feet here. And then here's the angle of elevation, and it's 14 degrees. Usually when you're doing handicapped or wheelchair accessibility, you want your angle to be pretty small. So here we go. How long is this ramp here? Well, let's see. With respect to 14 degrees, that 4 is opposite. That x is hypotenuse because I've got a right angle right there. So sine of 14 degrees, sine is opposite over hypotenuse, is equal to 4 over x. And since you're trying to solve for x, you're going to swap these because it's like saying times x, and then you're going to x sine 14 equals 4. Divide by sine 14, so you get 4 over sine 14. So x equals 4 over sine 14. Okay. Do we have any questions? I'm kidding, guys. I can't answer your questions. Put them in the comments. I'm like, it's a YouTube video. I'm not live. I guess maybe that should be the next one. I'm sorry if that happy face looks really crazy, because I noticed that the eyebrows make it look kind of like weird. So yeah, that's not getting any better. I'm sorry, guys. I'm sorry. Let's keep going. Draw a triangle ABC with side BC as a base. Okay, so here's my BC as a base, BC, and there's my angle A, and that says it's 60 degrees there. If a perpendicular is drawn from B to side AC, so let's draw that perpendicular from B to side AC. What that means is that that AC is perpendicular to this line here. So there it is. It's a perpendicular. It's 90 degrees right there. I tried to make it look as much as I could. And the height is 2 centimeters. So because this is my perpendicular, this is what's 2 centimeters. What is the length of side AB? All right, so recognize that this is a 30, 60, 90 triangle, guys. This is 60 degrees here, so that means this little guy has to be 30 degrees. And it's not drawn to scale. I mean, it kind of looks like it could be. In a 30, 60, 90, it's n square root of 3, and 2n. So they want to know the length of AB. So that's like saying the hypotenuse, because here's my right angle. So let's see, my height is the long leg, so this is 2. So we got to find n first. So the way to do that, we say, I'm going to do it right here, guys. N square root of 3 equals 2. And how did I get that expression? From the 60 degrees right there, guys. This side here is n square root of 3. This side here is n. And this side here is 2n. So you can already see what I'm doing. So n squared root of 3, which was 2. See? N squared root of 3 equals 2. So I'm going to divide by square root of 3. Divide by square root of 3. So you get n equals 2 over square root of 3. When I radicalize this, or rationalize this, sorry, you get 2 square root of 3 over 3. Radicalize, sorry. So there it is. So that's the small leg. And now I need to get the hypotenuse. So to get the hypotenuse, I just double it. So 2n equals 2 times 2 is 4. So 4 square root of 3 over 3. All right, let's go to the next one, guys. In a right triangle, ABC, with measure angle C is 90 degrees, and measure angle B is 46 degrees. Okay, so not to scale. There's my C, 90 degrees. AB, and B is 46 degrees. And AB measures 6 units. So 6, find length of AC. So I want AC. So I think, let's see, what's the best way to go here? All right, so with respect to 46 degrees, that 6 is opposite, and then that x, did I do something wrong here? Find the length of AC. Yeah, I did do something wrong, sorry. The length of AC is what I want, so that's x. AB is 6, so this is 6. So sorry, I almost did a wrong one there. So with respect to 46 degrees, that x is opposite, that 6 is hypotenuse. So you're going to write sine 46 degrees equals x over 6. So times 6 times 6, 6 sine 46 degrees will give me my x value. And there it is. So, bam. So hopefully I didn't confuse anyone there, guys. I fixed the errors. I noticed something was fishy. I'm not sure how I did that error, but yeah, we're back now. We're no more sad face. So let's keep going. Find the area of a regular octagon inscribed in a circle of radius 10. All right, so these are very famous for like SAT, ACT type questions. So you have a circle and you have an octagon. So that means you got 8 sides. So let's see if we can do an 8-sided one. You know what? I'm going to erase the circle and do my octagon first. 1, 2, 3, 4, 5, 6, 7, 8. So there's my octagon, and here's my circle. It's not perfect, but I tried to make it look perfect. Let me put the vertices in here so you guys can at least tell that. Okay, so those are my vertices right there. So I want to figure out what this area is. I know that the radius is 10. So I want you guys to see this right here. That's 10 and that's 10. They're both radiuses. And since this is an octagon, I know that one complete revolution is 360 and there's 8 triangles. So if you want this central angle, see, there's 8 there. If you want that central angle, I take the 360 and I divide by 8. So that means this guy has to be 45 degrees. All right, so if I want the area of this triangle, that's all I need. I need this side, that side, and then these 2 sides join at this vertex, and that's 45 degrees angle. So I can find my area. 1/2 10 times 10, and then this is sine of 45 degrees. So 1/2, and then 10 times 10 is 100. And I guess you can already put 50 if you want. And then sine 45 degrees is just square root of 2 over 2. The unit circle is not going away, guys, so might as well just know it. Half of 100 is 50. And with a square root of 2 over 2 still. And then 2 goes into 50 25 times. So 25 square root of 2. Now remember, that is just one. That is just one triangle. How many triangles do you have? That's right, you have 8. I heard you guys. Okay, I didn't hear you guys, but I can anticipate. So multiply 25 by 8. If you have 8 quarters, that's $2. So 25 times 8 must be 200. So there it is. 200 square root of 2. Hopefully that made sense to you guys. Find an area of an equilateral triangle with side length 5. Okay. Now that we honestly, they should have asked this one first because this one's actually easier than question 7. So its equilateral triangle has all sides congruent, 60, all sides congruent, and all angles are congruent on the side. So that means 5, 5, and 5. We can really use whichever numbers we want. It doesn't matter because they're all the same, right? So 1/2 5 times 5 sine 60 degrees. So let's see, 25 over 2. That's from that. And then sine 60 degrees, that's square root of 3 over 2. So let's see, 2 times 2 is 4. So 25 over 4 with a square root of 3 on the side. So there it is, 25 square root of 3 over 4. Square feet. Oh, I don't know why it does that sometimes. All right, here we go. If the area of a triangle ABC is 12 square meters, so here's ABC. So this is 12 square meters with little a being 10, so here's little a. And little b being 6, so here's little b. Find all possible measures for angle C.
You just call me a beach.
All right. No. Hey, stop. So if I want all possible angles for angle C, I'm just going to use my area formula because I want this guy. So I'm going to say x or theta. So I'm going to say 12 equals 1/2. And then 10 times 6 sine x. So let's see. Half of 10 is 5. 5 times 6 is 30, so 12 equals 30 sine x. And then I'm going to divide by 30. So divide by 30, divide by 30. 12 goes into 30. I guess 2 goes into 12 6 times. No, 6 goes into 12 2 times, and 6 goes into 30 5 times. So sine x equals 2/5. And then to get the angle, you would just take the inverse of that angle. So I'm going to go arc sine of 2/5. And we get 23.58 degrees. And since they're not giving us any restriction, so out, possibly, out. Well, there it is. It's C. Now, how do we get the 156.42, you may ask? Well, if you do 180 minus 23.58, so 180 minus 23.58, and you'll get your 156.42 degrees. So that's how you get the other one, guys. All right, let's go to the next one. Find the area of triangle UHV. No, they're not doing University of Houston Victoria, or maybe they are. Maybe they're being subtle. So let's see. Angle, not to scale. UHV. Angle U is 92 degrees, so it's almost a right angle there. Angle V is 28 degrees. And little u is 266. And little v is 125. Let me make sure I did everything right. Little v, yeah, everything looks good to me. All right, round your answer to the nearest 100. Find the area. So before I can find the area, I need this guy. So add up 92 and 28. So you get 120. And then subtract that from 180. And you get 60. Well, I guess we didn't have to do that. We could just put it in there, right? All right, so that's 60 degrees. And now that you got that 60 degrees, now you got everything, guys. Area is 1/2. 125 times 266 sine 60 degrees. So I'm just going to take my calculator, guys. Since I have all these decimals, I'm just going to literally take my calculator and just put it in. Insert that into your calculator. 0.5 times 125 times 266 times sine of 60. So I got 143. 143.97.67233. So there it is. Now let's keep going. The measure of the height of a cloud, you place a bright searchlight directly below the cloud and shine the beam straight up from a point 140 feet away. Okay, so here's 140 feet away from the searchlight. So here's the light right here, and it's pointing straight up. There's a cloud right there. You measure the angle of relation to the cloud to be 74 degrees. So that means this is 74 degrees. How high is the cloud? So I want x. So with respect to 74 degrees, that x is opposite. That 140 is adjacent. So we're going to use tan. So tan of 74 degrees equals opposite over adjacent. So 140 tan of 74 degrees will give us that x value. So we just type that in, guys. 140 times tan of 74. And I got a syntax error. There we go. I got 488. 488.238 feet. All right, go to the next one. A ramp leading to the freeway overpass is 200 feet long and rises 32 feet. So it already tells you it's 200 feet long. So here's the horizon, and 200 feet long. That's 200. And they tell you that it rises 32 feet. What is the angle of elevation of the ramp? So they want this guy. So that's opposite. That's hypotenuse, so you're going to use sine. So sine theta equals 32 over 200. That reduces, of course. I'm not going to bother. I'm just going to take the inverse of that. So 32 over 200, and let's see what we get. So arc sine of 32 divided by 200. Yay, how much fun is this, guys? Don't answer that. And you get 9.2069 degrees. And there it is. Yay. I hope you guys are happy. We're almost there. Relax. Find the area of triangle ABC where C is 90 degrees, A is 5, and C is 11. So here we go. Angle is 90 degrees here. So there's C, A, B. So little a is 5, so this is 5. And then little c is 11, so this is 11. So if this is 90 degrees, I need this guy here. So if I'm going to find this guy, this length, that's going to be the square root of 11 squared minus 5 squared. It's a right triangle. So the square root of 11 squared minus 5 squared, and I get 4 square root of 6. So this is 4 square root of 6. Now that we know that that's 4 square root of 6, well, we got this side, and we know that this is 90 degrees. That's all you need, guys. Area is 1/2 4 square root of 6 times 5 sine 90. Sine 90 is just 1. So no surprise, 1/2 base times height. If your base is this, and look, that's perpendicular to your base, so that's your height. So that's no surprise that that's your area formula. It looks pretty much the same. Let's see, 2 goes into 4 twice, so you have 2 square root of 6 times 5. 2 times 5 is 10, so 10 square root of 6, and there it is. Let's keep going. We got a few left. So we have a triangle, XYZ. XYZ. Angle Y is 60 degrees. Little z is 9, and little x is 5. So it wants the area. They give me everything I need. They're making this easy for me. 1/2 5 times 9 sine 60 degrees. So let's see. So 9 times 5 is 45, so the 45 over 2. And then sine of 60 is square root of 3 over 2. So 45 square root of 3 over 4. There it is. Find the area of triangle GHJ. So not to scale. Let's see. GHJ. G is 135 degrees. Little h is 10. Little j is 15. Again, they're making it easy for me. This is the angle I need. Here's 15. Here's 10. So that's everything I need, guys. Area equals 1/2 15 times 10 sine 135. So let's see. 15 times 10 is 150. 150 divided by 2, I believe, is 75. And then sine of 135 is square root of 2 over 2. And so there it is. So that's it. 75 square root of 2 over 2. Yay. Look, they even gave us a hint, guys. In triangle ABC, the measure of angle A is 2x. The length of AB is 11. All right, so let's draw this triangle. So ABC. A is 2x. The length of AB is 11. The length of AC is square root of 30 over 20. And if sine x is 1 over 11, what is the area of the triangle? Okay, so I have everything I need. On the side, guys, look what they tell you. Sine x is 1 over 11. That's right here. So on the side, I'm going to draw a right triangle. There's angle x, 1 and 11. If that's true, 11 squared is 121. 1 squared is 1. 121 minus 1 is square root of 120. And square root of 120, I believe that breaks down to, 4 times 30. 4 times 3 is 12, so 4 times 30 has to be 120. So this breaks down to 2 square root of 30. All right, that's it. We got everything. So area. Area is 1/2 times 11 times square root of 30 over 20 sine 2x. But sine 2x is 2 sine x cosine x. And we have this, guys. We have this here in our blue little calculator, our blue little triangle there, sorry. So here we go. So I'm going to write it like this. 1/2 times 11 times square root of 30 over 20 times 2 times, let's see, sine x. So really I should put the 2 in blue here. 2 sine x is 1 over 11. So 1 over 11 times cosine x is 2 square root of 30 over 11. So I'm going to write 2 square root of 30 over 11. So there it is. So let's see what cancels. I have an 11 and I have a 1 over 11. Out, out. I have a half and I have a 2. Out, out. So let's see. Square root of 30 times square root of 30 is 30, and I have a 2. 2 times 30 is 60. And 20 times 11 is 220. So that reduces 60 over 220, reduces to 3 over 11. There it is, guys. All right, let's keep going. Is this the last one? Yay, this is the last one, guys. In a acute triangle, oh look, it's a acute triangle. Okay. In an acute triangle ABC, the measure of angle A is 2x. So let's draw a triangle. A, B, C. So A is 2x, and the length of AB is 4, and the length of AC is square root of 3. Excuse me. If sine x is 1/8, so again, they're giving you what sine x is. What is the area of the triangle? Again, we're going to do the exact same thing, guys. Area equals 1/2 times 4 times square root of 3 sine of 2x. But remember that sine of 2x equals 2 sine x cosine x. So now that we know that, let's go ahead and draw a little triangle here. So let's see, here's angle x, 1/8. 8 squared is 64, 1 squared is 1, so this is square root of 63. And square root of 63 does break down to 9 times 7. So that means this is 3 square root of 7. All right, now we're good, guys. So here we go. Area, I'm going to write it down here. Area equals 1/2 times 4 times square root of 3 times, and then I'm going to write this, 2 times sine x, which is 1/8, times cosine x, which is 3 square root of 7 over 8. All right, let's see what cancels. What can we cancel? I have a half and I have a 2. I like to start with that. I have a 4. 4 goes into 8 2 times. So I'm going to take that and turn that into a 2. And it looks like that's it. All right, so let's see what we get. So square root of 3 times 3 square root of 7, that is 3 square root of 21. 7 times 3 is 21. And then I have 8 times 2, which is 16. And there it is. 3 square root of 21 over 16. All right, guys, I hope you guys enjoyed this video. I guess please give it a thumbs up. It would be nice. I guess if you want to get a thumbs down, I try not to, I guess. But, yeah, be happy, guys. You want to tell them anything?
Hope you got that 100. And if you didn't, good luck.
Yeah.
Try again.
Super awesome. Okay. All right, guys. Good night. And I'll see you guys when I see you guys. Later. Bye.
Why do you do it like you're talking on the phone?
Oh.